How do electric vehicles work? Have you ever wondered how electric vehicles go from point A to point B? Is it just an internal combustion engine connected to a massive battery? Or is there some other, more subtle trickery at work? If you want to discover more about how electric cars, often known as EVs, function, and the differences between pure and hybrid electric vehicles, join us today as we open the hood and investigate how electric engines work. Hello guys, how's your day going? Hope you're having a great time. Before we proceed with this video, do not forget to subscribe to our YouTube channel. Kindly click on the notification bell to get updates on our exciting content. Surprisingly, most modern electric vehicles' functioning mechanism predates the internal combustion engine by a good number of decades. Sybrandes Strating, a Dutch professor from Groningen, created his own little electric car in 1834. The catch was, it didn't have a rechargeable battery. Well, we don't get to talk about the vehicles without understanding the mechanism behind the engines first. So, how does the electric car engine work? Electric cars work by hooking into a charging station and pulling power from the grid. They save electricity in rechargeable batteries, which are used to power an electric motor that pivots the wheels. Electric vehicles accelerate more speedily than vehicles powered by standard gasoline engines, making them feel lighter to drive. How does charging work? An electric car can be charged by hooking it into a public charging station or a home charger. While you're out and about in the US, there are plenty of charging stations to keep you ultimately charged. However, in order to obtain the most excellent bargain for home charging, you'll need to choose the proper EV power tariff, which will allow you to spend less money charging and save more money on your bill. Well, if you're new to car stuff, this might be a very bitter pill to swallow. Let's try going really slow on the entire process. The combustion part of internal combustion engines works on the idea that when fuel and air are compressed and ignited, they produce a small explosion. A piston is pushed by this explosive force. A mechanical crankshaft converts the linear motion of that piston and a group of other pistons into circular motion. As a result, your wheels spin along the roadway. The underlying principle that drives electric cars, on the other hand, is magnetism. Everyone understands how a magnet's opposing poles attract each other and how like poles repel each other. Assume you're doing an experiment with two magnets, one fixed and the other is installed on a revolving shaft nearby. Because the magnet on the shaft is coupled to a shaft, it will be repelled if the two poles closest to each other on the magnets both have the same polarity, say north to north. The shaft will turn until the south pole of the shaft magnet aligns with the north pole of the fixed magnet, at which point it will stop. We've made the shaft turn a half rotation in our hypothetical experiment, but it won't get us very far on the morning commute. The shaft of a fixed or permanent magnet, such as the one on your refrigerator, is where electromagnetic enters the shaft. Those magnetic poles are rigid and never change. North is always north and south is always south. This magnetic polarity may be reversed in an electromagnet, which is essentially a metal core coiled in electrical wires. Assume that one of our experimental magnets has been transformed into an electromagnet. If the south pole quickly flips over to the north, the fixed magnet repels the moving magnet once more. As a result, our shaft rotates another half spin. That's quite a turn. We're getting closer to our desired location now. For a basic illustration of how this polarity reversal works, imagine a very simple circuit involving a battery and a light bulb. Electrons flow in one direction from the battery to the light bulb, then back to the battery through the wires. If we take our battery out of the circuit, rotate it 180 degrees, and then replace it in the circuit, the electrons will continue to travel through the circuit, but in the opposite direction. The lamp turns on in either case. Electromagnets, like light bulbs, work in any direction that electrons flow. But the polarity of the magnet is reversed with the flow of electrons, which is quite dazzling. So all we have to do is continuously reverse the polarity of our magnets to maintain them in permanent repel mode. The puzzle now would be, how do we do that? One method is to keep removing the battery and flipping it over, but that's a lot of visits to the mechanics in your EV just to cover a few feet of ground. The fundamental secret to a spinning magnet, which is how electric motors work, is to use an inverter. The inverter module on the EV draws direct current from the car battery and, through a clever combination of quick switches, slick circuitry, and capacitors, flips the flow of electrons back and forth about 60 times a second. Domestic electric motors, such as the one in your hairdryer, don't need an inverter because the current in your power socket already flips back and forth. As a result, it's known as alternating current, or AC. Any sort of battery can only provide DC, or direct current. Electric automobiles are powered by spinning magnets driven by alternating current passing through coils of wire. Aside from internal combustion engines, there are also electric powertrains. Electric powertrains have a number of advantages over the internal combustion engine. For starters, the motion produced by the motor is already rotary in nature. Dirty pistons on a block of ice require a complicated breakable crankshaft, just in order to turn their linear motion into rotary motion. So, EVs are less likely to fail or need expensive time-consuming maintenance. Here's another clever thing about that powertrain inverter. By adjusting the frequency and amplitude of its newly created AC current, the vehicle's speed and torque can be finely calibrated by its driver. There are no such tight controls built into an explosively hot internal combustion engine. This is actually the reason it's so expensive. Accident-prone additions like gearboxes that are usually found in these models are tiresome necessities. Another attractive detail about any EV's powertrain is, when the shaft-mounted magnet, or rotor in engineering parlance, is self-spurned, it generates electricity. This reversal very handily recharges the car battery. You may ask how the rotor can be turned. Well, the rotor can be turned with any hefty source of kinetic energy, say, a braking automobile that is handy. To be clear, a very simple overview could be imagined. Well, with this amount of power driving your EV, how far you can travel on a full charge depends on the vehicle. The range, battery size, and performance of each model vary. The typical electric vehicle for you will be one that you can drive on normal trips without necessitating you to stop and charge halfway through. There are different types of the electric motor out there. Refinements to the design are happening all the time. For starters, a particular Californian car company named for the 19th century genius who discovered the magic of alternating current. What varieties of electric cars are out there? Electric vehicles come in a class of sizes and shapes. Hybrid electric vehicles may run on gasoline or diesel as well. Pure EVs, on the other hand, are those that run entirely on electricity. Plug-in electric. A plug-in electric car is one that runs solely on electricity and takes all of its power when it's securely plugged in to charge. This type does not use diesel or gasoline to operate, and hence does not emit any pollutants like ordinary cars. Plug-in hybrids chiefly run on electricity, but they also contain a traditional fuel engine that can run on diesel or gasoline if the battery runs out. These cars create pollutants when they run on gasoline, but not when they operate with electricity. These sort of EVs may recharge their batteries by plugging them into an electrical outlet. Hybrid electric. These vehicles run mostly on gasoline or diesel, but they also feature an electric battery that is recharged by regenerative braking. At the simple stroke of a button, you may switch between running your gasoline engine and operating EV mode. These vehicles are unable to get attached to an electrical source and must rely on diesel or gasoline for power. There you have it, how electric vehicles work. What do you think? Do you think you can discuss this process with your eyes closed? More importantly, is the idea of owning an electric vehicle very exciting? Let us know in the comments. If this video was insightful, don't forget to like this video. Don't forget to subscribe to our YouTube channel and click on the bell button to be notified whenever we upload videos like this one.